Welcome back, my students, and today we are on lesson 25. We're going to talk about solution of equations. So in the previous two lessons, we learned the two rules for solving equations, and that is that the same quantity can be added or subtracted to both sides without changing the answers to the equation. Basically, we keep them balanced, and that every term on both sides of an equation can be multiplied or divided by the same non-zero quantity without unbalancing the equation or changing the answer either. In many equations, it's necessary to use both of these rules to find a solution. For instance, in this equation, we have 3 times 4 minus 2 equals 10. That's our equation. Okay? So what we would do first is add 2 to both sides, which would cancel that out and give us 3 times 4 equals 12. Then we would divide by one of these numbers. We'll use 3. That would cancel out, which would leave us 4 equals 12 divided by 3 is 4. We know we did that correctly. And in doing the same thing to both sides, we kept the balance and we made the statement stay equal on both sides. So that just proves that as long as we do the same thing to both sides of the equation, whether it's addition, subtraction, multiplication, or division, as long as we apply it to every term on both sides, then we know that the statement remains true. The equation remains equal or balanced. And that's our goal. We cannot find the true result unless they're all balanced. So let me clear the page. And let's jump into an example problem. Let's start with 25.1. We have 4x plus 5 equals 17. Okay, work it with me on your paper. So the first thing we need to do is we need to do the opposite, which is to subtract 5 from this side. So we're going to do that to both sides to maintain the stasis or the equanimity of the problem. So minus 5 minus 5. This cancels to 0. This leaves 4x on this side, and 17 minus 5 is 12 on this side. We don't know what x is, so we'll divide by the number we do know, which is 4. These two cancel because a number multiplied by and divided by the same number cancels each other out. Okay? So we're left with x equals 12 divided by 4 is 3. So the answer to 25.1, x equals 3. Let's do 25.2. Alright, at this point I want you to pause the video and work the problem, and then come back, press play, and see the answer. Alright, so if you got m equals negative 2/5, then you got the right answer. So we subtracted 6 from both sides, then we divided both sides by negative 5, and know that you cannot have a negative in the denominator. It must move to the numerator. So m is equal to negative 2/5 or negative 2/5, however you want to say that. All right, moving on. Let's do 25.3 right here. I think it'll fit. All right, negative 7k minus 4 equals negative 21. So let's do this again. Pause, work the problem, come back and see if you have the right answer. All right, if you got k equals 17/7, that is the correct answer. We added 4 to both sides so that we could eliminate this. That gave us negative 7k equals negative 17k, so we divided on both sides by -7, and the -7's canceled each other out. We eliminated them, factored them out, and we cannot have, well, we can't, when we divide a negative by a negative, two negatives cancel each other out. So we can't have a negative here that's going to be a positive. So k equals a positive 17/7. All right, let's clear the page, pause, and take notes if you need to. And listen, as you take your notes, you need to write down the steps, okay? And the steps are here. Step 1, you are eliminating constants or whole numbers by adding or subtracting. Okay. Then once you get it down to a factor with a variable and a whole number, then you divide. Okay, and then you have your result. And you can possibly simplify that result. All right. Those are your steps for these simple equations. Let's clear the page and move on. 25.4. All right, -11p plus 5 equals 17. So first we subtract 5 from both sides. Okay, so we can eliminate this constant here. Now we bring down our -11p and we subtract here. So that's going to be 12. So now we have two factors here. So we divide by the factor we know, which is -11. So we divide both sides because we need to keep them equal. These two cancel each other out. So p is going to equal -12/11 because the denominator can never be negative. The denominator is always a positive. Okay, because the denominator is just a descriptive of how many pieces are in the fraction, how many parts that fraction is broken into, and when it just tells how many is in the set. This, the numerator, tells you the number of pieces you have available in the set. This is why it can be positive or negative. In this case, we are missing 12 pieces, so we're missing one whole set and one piece of another set. Okay, that's what this is telling us. We have to think of it in those terms. This is how many pieces are in the set, and this is how many pieces we have. Okay? All right, 25.5. All right, in this problem, we have some fractions to deal with. So we're going to, first, we're going to do the same thing we did before. We're going to add 1/2 to both sides. Okay, and these two will cancel out. And then we'll have 1/5 of m equals, but what we have to do here is put this in a format that we can easily add to this. So that means we have to look at the denominators, and this is 4 and this is 2, so we need to multiply this whole fraction by 2 so they have a common denominator. So this is going to end up being 2/4. Okay, 2 times 1 is 2, 2 times 2 is 4. 2/4 is still the same value as 1/2. So now we can add them together, and that's going to give us 5/4, and that's what we'll put here, 5/4. Now, when we have a fraction with a variable, the way we get rid of that fraction is to multiply by the reciprocal of that fraction. So we flip it and multiply, and we do that to both sides. So we're going to say 5/1 times this, and we'll do the same thing over here. 5 over 1 times this. So when we say 5 times 1, we have 5, and 1 times 5, we have 5. 5 over 5 is 1m. So these cancel each other out. M is equal to 5 times 5 is 25, and 4 times 1 is 4. And that is the answer for 25.5. All right, we have one more, and I'm going to let you work that one yourself. All right, our problem this time is in decimals. So remember how to get rid of decimals and then solve the problem. All right, I'm going to pause, and you pause and work the problem, and then press play and see if you got the answer right. All right, we have two possible ways to solve this problem. First of all, you could get rid of your decimals by multiplying every term by 100. Remember, if we multiply every term in an equation by the same number, then it stays the same. And that allows us to deal with whole numbers. So we multiplied all these numbers by 100 because we had two decimal places here, so that's 2 zeros. So 2 zeros is 100. So we multiplied 0.4x times 100, we got 40x, 0.2 would be 20, and 0.16 would be 16. Then we had whole numbers to deal with. We ended up with x equals 1/10, which if you divide 1 by 10, you're going to get that equals 0.1, okay? Or you could retain the decimal format. It's a little bit more complicated, and you have to make sure that you line your decimal points up when you're doing the math. If you don't make sure those decimal points are stacked on top of each other, then you'll skew over and get the wrong answer. So if you're good at keeping those decimal points aligned, you can do it like this and actually save a step, and that's fine. It's up to you, as long as I get the right answer at the bottom. Now in this instance, if you typed in 1/10 or you typed in 0.1 and the system didn't tell you it was right, leave it and let me make sure, and I will check it for you. Okay. Now most of the time, if you type in 1/10, it's going to take it and say that it is the same as 0.1. Or if you type in 0.1 and I've typed in an answer of 1/10, it's going to say it's the same thing because the decimal can convert those two. But this must be in a fraction format or it will not convert it. That's why it's so important to use your special character keys in Jupyter Ed. All right, so let's see, do I have any? No, that's it. That's all that we have for lesson 25. So I will see you in lesson 26.